Okay, piecewise functions, they look a little bit scary, but stay with me for a minute. All right, sketch the graph of each function. Well, notice this is saying that this function right here is broken into two pieces. This piece and this piece. A tip would be just look at them one at a time. So this first function right here essentially just says f of x is equal to 2. Well, that's a constant function, right? So where 2 touches the y-axis, there'd be this horizontal line, right? However, this right here says, hey, the only part of the graph that we care about, oh, I should have rotated that. Let's see if I can. Yeah, it didn't let me. Anyway, where the x values are greater than or equal to -3. So imagine if that arrow was going in the opposite direction. I'm going to still see if I can do that. No, it's not letting me. Anyway, so, and notice there's a solid line, so there would be a solid dot right there at 3, and the graph would be going in that direction right there. All right, so now we're going to graph this other function. Well, it's the square root function. Normally the square root function starts here at 0 and does this type of thing. But this is saying, let's see, there's a negative sign on the inside. So let's put, if we put 0 in there, it's still going to touch at 0. Oh, all we care about are the values that are less than -3. Let's put -3 in there. Well, -3 times -3 is 9. What's the square root of 9? +3. So at -3 right there, here, let me change that color. At -3, when we plug -3 into there, we're up here at +3. But we have to put a hollow dot because of the inequality sign. Well, that's this graph. That graph would look something like this, but what is the domain? This is called a domain restriction. These things right here, this tells us what the x values are doing. Well, now what we care about is just where all the x values that are less than -3. So I'm going to take my eraser and I'm going to erase all of this stuff. I'm really going to erase that so there's just a solid dot. And I'm going to put a hollow dot right there. And this is it. And this gap right here in that function, that is called discontinuity. Meaning this function right here is not fully continuous. It's continuous that direction, it's continuous from here in that direction, but right there where x is equal to -3, you have a discontinuity. All right, so we're going to come over here and do this one. We have a 2x minus 4. Well, that's just y equals mx plus b. So at -4, so let me go ahead and get this graph right. I've already pre-done that. Whoops. That graph would look something like that. But notice the restriction. The restriction says the only part that we care about is when x is equal to -4 and less than that. So I'm going to follow the graph up to -4, solid line, solid dot, and all of this other stuff can go away. So that's that graph. And now we have a cubic. Well, but look at this cubic. If it's inside the parentheses, remember, it's shifted the opposite of negative 5 is positive 5. So here is kind of a basic cubic function that, let me bring that out in front. It may not let me. Yeah, I might have to redraw it. Yeah, I'm going to have to do that. Sorry about this, people. All right, so normally a cubic function would have started here, would have hit there, 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 and down here. But this tells us it has been shifted over 5 places. So I'm going to just shift that over. It would look like that now. Oh, look what I did here. I did that at negative 4. It should have been positive 4. So I'm going to have to rethink that a little bit. We would have been down here. Sorry about that. So that graph would have looked like this, and it would have just kept going down, just like this. This graph, this cubic, says the only thing that we care about are all the x values that are greater than 4. So there can be a hollow dot right there. And all of this stuff goes away. And where x is equal to positive 4, that's where there is a discontinuity. All right, that's it for, let's see, let me come over here. For inequalities, this is going to be a little bit longer. So solve each compound inequality. This is a quick review. When there is an expression in between two inequality signs, that's an and statement. And when it's an or, there's usually going to be the word or they'll just have two separate. So what you're going to do is you're going to break this up into 2 different inequalities. And so how you do that is, look at what I've done. The a plus 5 and the a plus 5 goes to each one, and then you just solve. So I'm going to subtract 5 both sides. And then I read it starting from this says a is greater than or equal to negative 6. So at negative 6, a are all the values greater than negative 6. Let's see what we have here. We're going to subtract 5, subtract 5. A is less than or equal, solid line, solid dot. Did I? Yeah, they're both solid lines, all right? A is less than or equal to 4. So solid line at 4, and we're going to go this direction. And on an and statement, where these two overlap, that's the solution set. So interval notation would be negative 6 to positive 4. All right? For an or statement, you're going to solve. We're going to subtract 1 both sides. 6r is less than or equal to 0. Well, that means r is less than or equal to 0. So at 0, r would be all of the values smaller than 0. And then over here, we're going to subtract 5. Here, let me change that color. Subtract 5. That gives us negative 3r is less than negative 12. Here's the tricky part. Remember on inequalities, when you divide or multiply both sides by negative, remember this was negative, this was negative. When I divide by negative, this is now positive, this is now positive. The signs change, so we have to change the inequality. This now says that r is greater than 4. So we come over here, put a hollow dot at 4. And so notice most of the time, not always, most of the time when they're or statements, they're going to be going in opposite directions. And when they are and statements, they overlap each other. All right, that's it for this one.